The next part of this section involves making factor trees, and we're going to use factor trees to write prime factorizations of numbers. So it says one way to find all the prime factors of 23 is using a diagram called the factor tree, and it's shown below. So prime factors of 24. I've got 24 right here. The first thing you want to do is break up the number into two of its factors. So I know 3 times 8 is 24. So that's why I did 3 times 8. And then I stop when I get to a prime number. I learned in the previous video that 3 is a prime number. So I don't have to break that into 1 times 3. I just stop there. But then for 8 can be broken down into 4 times 2. 2 is a prime number. Nothing goes into it except for 1. So I stop there. But I can break down 4 into 2 times 2. And that would be finding all the prime factors. So the prime factors would be 2, 2, 2, and 3. All the ends of the branches. Another way, so you don't necessarily have to start with 3 and 8. You might start with 6 and 4. And I forgot to, so try to get into the habit of circling the ends of your branches for these factor trees. So again, my prime factors were 2, 2, 2, and 3. And if I were to start with 6 and 4, I should still get the same prime factors. So 6 can be broken down into 3 times 2. 4 can be broken down into 2 times 2. Now all the ends of my branches are prime, so I circle them. And I have 3, 2, 2, and 2. Same as I did over here. You might have even chosen to do 12 times 2 first. Okay, so 12 times 2 should still work. 12 can be broken down into either 6 times 2 or 4 times 3. I'll do 6 times 2. And then 6 is 3 times 2. Again, I get the same prime factors. Okay, so these are the steps to making a factor tree. Now, you don't need to write these down if you know how to make factor trees already, but here they are written out for you. So, number 1 is to write the composite number you're factoring, like we did, 24. And then make 2 branches coming from the number where the 2 numbers at the ends form a factor pair, just like we did here. Number 3 is break down each of the numbers at the ends of the branches into another factor pair, just like we did here. And then we stop when we have all prime numbers at the end. So those are just written out. So it says if you circle all the ends of the branches, so where the branches stop, and write them as a product, you have what's called the prime factorization. Prime factorization. So, the definition of a prime factorization is when an integer other than 1 is expressed as a product of factors that are all prime. So an example would be what we did up here. We wrote, we're pretty close to writing the prime factorization. So we'll say prime factorization of 24, we worked with 24, would be 2 times 2 times 2 times 3. You always want to start with the lowest prime factor. Another way this can be written is 2 times 2 times 2, well, that's just 2 to the 3rd power times 3. So that's the more condensed way to write your answer. And either of these would be the prime factorizations. So let's try an example. It says use a factor tree to factor 72 completely, and then write the prime factorization. So we're going to start by making a factor tree with 72. Now you could start with any factors you wanted to. I'm going to start with, let's say 9 times 8, because that's maybe just the first one I thought of. Okay, 9 times 8 is 72, and then 9 can be broken down into 3 times 3. Both of those are now prime, so I stop there. 8 is just 2 times 4, and then 4 is 2 times 2. Now I have all prime numbers at the ends of my branches. So I can rewrite this as 2 times 2 times 2 times 3 times 3. Or the more condensed way would be 2 to the third times 3 squared. 2 times 2 times 2. Yeah. Now, it is important to note that this is just another way of writing 72. If I were to type in 2 times 2 times 2 times 3 times 3 in a calculator, I should get 72 if I did it correctly. If you don't get 72, then something must have went wrong in your prime factorization process. Okay. We'll do one more example. It says use a factor tree to complete 60 or to factor 64 completely and then write the prime factorization. So I'm going to start with 64. Maybe the first one I think of is 8 times 8. You could think of 32 and 2 or 4 and 16. It doesn't matter. Each of the 8s I'm going to make 4 times 2. And then 4 is just 2 times 2. And now all the ends of my branches are prime. So I circle them anywhere there's an end. And wow, I've got a lot of 2s. So this is just 2 times 2 times 2 times 2. There's 6 of them. 1, 2, 3, 4, 5, 6. And that can be written as 2 to the 6th. So this is the prime factorization. And again, if I typed in 2 to the 6th in my calculator, I should get 64. And I do. Okay, last one. I'm going to use a factor tree to factor 60 completely and then write a prime factorization. So 60 has a lot of possibilities. I might think of, I'm going to do 30 times 2 first. You might use a different one first. And then 2 is prime, so I'm going to go and break up 30 into either 10 and 3 or 6 and 5. Either of those work. 5 is prime, so I stop there, but then 6, I can do 3 times 2. So circle all the ends, and I've got 2 times 2 times 3 times 5. Remember, we want to write our factors in increasing order. So this is the same as 2 squared times 3 times 5. And I have my prime factorization.